Hi friends, a very good evening and thank you for joining in. Could you please confirm in the chat window if I'm visible and audible so that we can get started with today's session, and we'll start it in a few minutes. We'll start the session itself at 7:02 or so, as soon as a bunch of people join. Anyway, most people join by 7:01 or 7:02. Okay, good. Thank you folks. Thank you for the confirmation. So we'll get started in a few minutes. Since we have about 3-4 minutes before we start the actual problem solving itself. Again, last time we were just getting started, so there were some fairly easy problems. This time there will be a few easy problems, few medium, few tricky questions. Again, we have a total of 4 live sessions for C programming, because it's an easy topic in which you can easily score. If you know the concepts well, you can score, right? So we'll keep increasing the difficulty slowly and steadily so that you know where you stand. Okay. So test series, just be patient. We will hopefully announce it sometime this week or early next week. Yes, Suhail, thank you for that. I've almost, our team has almost finished the analysis of C programming also. So I will put out that video hopefully in a day or two. Okay, we'll surely put out that video. For every subject, as we go through the subject, we will post the marks analysis. That's a good point. It's something that we've been working on. We just wanted to do that analysis more thoroughly, and we will put it out for sure, right? Just give us a couple of days. Okay, let me look at the chat window here. Deepyan says, okay, so let me just anyway open the window here itself so that I can see the comments as I look at the screen. Okay. So let me look at the chat window on my phone. That might be better. So Deepyan says how to focus on gate prep as I'm involved in office stuff a few times a week. Deepyan, we have a lot of students. We also worked with a lot of students in the previous years who are working professionals. The simple rule of thumb, if you're a working professional, is you allocate time early in the morning and preferably late in the evening, so that you have dedicated office hours where you work only on your office work, because you want to give your best to your office work. Don't ignore it. So maybe 2 hours in the morning, 1 hour in the evening, whichever distribution you want. So try and allocate roughly about 3 to, if you can squeeze in 4, that's great, but at least try to put in 3 hours. Have dedicated slots. You say, hey, from morning, let's say 6 to 8, I'm going to only work on my gate prep. Rest through the day, probably from 9:30 a.m. to about 6 or 7, I'll work on my office stuff, take a break again, probably work for 1 or 1.5 hours again in the night. It is by having these allocated time slots where you will focus on, think of it like your daily scrum, right? That you have at your office. So try to have a scrum with yourself and do your gate prep accordingly. That works magically well. Of course, you will not see results immediately, right? You will not see results after 3 days or 4 days. You'll see results after a month. And that's what is important. Gate prep is a few month journey. It's not a few days journey. That's important to keep in mind. So Ankit says, please add some MSQs in practice tests. Sure, Ankit. So we have put most of the MSQs in the test series, both 2021 and 2022 test series. Remember that MSQs were only introduced and we came to know of it only last year, October, November. It takes more time to create them. So slowly and steadily, the number of MSQs will increase. This year test series has more MSQs than the last year, because we came to know of it very recently. And designing these questions from scratch takes considerable effort, but we'll surely add more as we go. How much time is required for TOC? This is from Sanjeev. Again, different students learn at different pace. So there is no one time slot that we can recommend. But roughly speaking, if you take only TOC and not include compiler design, you should be able to comfortably finish it in maybe 2.5 to 3 weeks. I'm talking about an average student, and there will be some students who are not comfortable with the mathematical thinking in TOC, especially the later topics, and they might struggle a little more. See, everybody has their strong areas, right? So I might be able to finish TOC because I'm stronger in mathematics. I might struggle with another system subject because I may not be good at it. So it all depends on which subjects you are closely comfortable with. So there is no one single formula for every subject. Okay. And once you do TOC, compiler design becomes very easy because you're piggybacking on the TOC concepts for compiler design. So this is from Vasu, who says, what's the best time to learn Gate in a day? Again, there is no one right time, to be honest with you. I am more of an early morning guy. I try to get most of my work done early in the morning. But I've also, like during my BTech days, I was a night owl. Okay, because I used to like work till 2 a.m., start my work at 10 p.m., hang out with friends, come back home. 10 p.m. I used to actually start studying, and I used to sit till like 2 a.m. So I was a night owl in my BTech days, and I could never do stuff early in the morning. As I aged, I started becoming more of a morning guy, because I want to spend my evenings with my later part of the evening after these live sessions with family, and all the responsibilities kick in. So I'm more of an early morning guy, because my son is sleeping there. I get more peace of mind. I'm more fresher. I don't have the exhaustion of the day. So there is no one right time to focus on any learning. It could be GATE, it could be interviews, it could be anything. There is no one right time. Undergraduate days, most students tend to be night owls. So you can either put time at night or you can do early morning. One recommendation, if I may, is try to split into 2 slots. Don't try to have just 1 slot. So you might just squeeze in half an hour in the morning. That's okay. That half an hour you can revise whatever you learned the previous night. So try to squeeze in half an hour to 1 hour in the morning or evening. In the other, like if you're a night owl, spend more time at night, but try to squeeze in like half an hour to 30 to 60 minutes early in the morning. Having these 2 shifts is helpful, because whatever you learned early in the day, you can revise at night, or whatever you learned at the night, you can quickly revise and solve a few problems at in the early hours of the day. Middle of the day, again, if you're a working professional, you may not get enough time between your meetings and work. If you're a student, between your classes, exams, etc., you may not get time. But if you have a summer vacation, or some of our students preparing full time, just get good breaks. Try to put in 8 hours a day, because you're putting in full time, right? You should think of it like a full-time job. Okay, cool. So Ankita says, please tell some tricks for pointer questions. We have a lot of pointer questions. This week, we are just starting off with pointer, so there are easier questions. Next week, sorry, in the next live session, I'm sorry, not next week. In the next live session, we will see some of the trickier cases that you're talking about, which is array of pointer to arrays, and again also function pointers, etc. We will see that in the in the next week, in the next live session, where you'll see some of those trickier concepts. Cool. So Somesh says, I attempted linear algebra and I got 40%. Dude, that's good. Don't worry about it, Somesh. That's actually pretty good. So in the very first time, you read through the concepts and you attempted the test that is there and you got 40%. That's actually good, because we've seen a lot of toppers last year who actually got only around that 40% marks, and they worked from somewhere around June, July, August. They worked through till February consistently, and that's actually good. You're on the right track. Don't worry about it. You have not got 10%, right? So that's still okay. If you've gotten 10%, then you have to put in more effort and hours. 40%, you're like an average student. You just need to be consistently working towards the GATE exam. Okay, folks, I completely lost track of time. So let's get started. As usual, let me start sharing my screen. Could you please confirm if my screen is visible and audible? Is my screen visible and am I audible? Mixed those two. Could you please confirm so that we can get started with today's session? Okay, let's get started, folks. So this is C programming part 2. I'm sorry, I've overshot. I wanted to start at 7:02. Sorry for that. We will have a Q&A at the end. So today's topic is pointers and arrays. We will solve the simpler of problems in pointers and arrays. Again, we have 4 live sessions, 1, 2, 3, 4 for C programming. 1 was fairly easy, 2 slightly harder than this. As we keep moving forward, we will keep giving you more and more trickier questions, more and more questions which are considered medium, tricky, hard questions by GATE standards. Okay, so today it will be a blend of both. Cool. So let's get started with our first question here. Here is the first question. Take your time, think through it, don't make silly mistakes. All the live sessions for C programming, data structures or algorithms, we are putting them out publicly so that students who have placements also benefit from it. I already see various answers in the chat window. Please make sure that you revisit your answers, because obviously it's an MCQ, only one option can be correct. So please revisit your answers. Again, this is an easy question, slightly tricky. If you're not careful, you'll make mistakes. I see almost all the 4 options being given as answers by students, A, B, C, D. So please revisit your answers. Take a few more seconds. It's a simple question, slightly tricky. That's why I see such variability in answers. So this question is mostly easy plus slightly tricky, I should say. It's not actually tricky, it's simple. Okay, given that a lot of you have put in your answers, let's go into the solution itself. Okay, here it is. So int main, cool. So you have array, like a character array where you have hello stored, right? So you know how character arrays are stored. String is basically a pointer to HELLO, right? So this is basically a character array that you have. Cool. Now what you have here is you have a constant pointer p, which is equals to s, which means this constant character pointer p will also point to this as expected. Cool. Because string is basically internally a pointer to the first location. This is 0, 1, 2, 3, 4. Standard C stuff. Till here everything is cool. Now here comes the slightly tricky thing where people might commit a mistake. So what does this statement say? Some people might say, hey, this is error, but it is not, because you're not changing a constant pointer. The constant pointer itself is pointing to the same memory location. Let's assume this address is some 2000. We are not changing p itself. P is pointing to 2000 itself. We are changing the value stored at p. Look at this. The value stored at p, we are changing it to m. We are not changing p. So we are saying whatever is the value stored at p, and p itself has the value 2000 because p is a pointer. Right? Let's assume this address of the first cell is 2000, starting from 2000. Let's assume this is starting from 2000. So this will get changed to m. So this is not an error. This is perfectly valid statement. And what it's literally doing here is, you're not, again, the key thing here is you're not changing p, you're changing the value stored at address p. Okay, that's how you should read star p, right? Once you get this, it's all straightforward. You're just saying printf %s(n). So what is %s? MELLO, because by the way, so there will be a \n here. I'm sorry, I forgot to write that. Okay, because it's a string, it will be stored with a escape character at the end. So %s is, %s is going to be MELLO. Okay, and then you have n here. Remember, this is the other small catch here where some students who said B, probably they didn't see the n here. So this n will be printed as n itself. So what would it print? It would print melon. So C is the right answer. Those of you who said D is the right answer, probably you got confused that we are changing pointer P. We are not changing pointer P. We are changing the value that is stored at address P. Right? So that's perfectly valid. Those of you who might have said B probably ignored this N. That's why I said this is an easy question, but a slightly tricky one. Okay, I hope everybody is convinced that C is the right answer. Again, that's why I told you, right? Again, more and more as we see in the last few years, we are observing that GATE question paper is becoming slightly trickier and trickier. It's not hard. There is a subtle difference between tricky and hard. Tricky basically means There will be a lot of places where you can fall into a trap. For example, this is a trap. Similarly, this is a trap. If you don't have perfect conceptual clarity, and if you're not careful in seeing the code and reading the code or reading the question, you'll fall into those traps. Okay, so we see more and more. So this question is fundamentally an easy question. You can't even say it's a medium question. It's just that it is tricky, making it slightly more like a medium question. If you're careful with this, you will get it. Sorry, did I say \n? I'm sorry. Oh, sorry, it's \0. It's not \n. I'm sorry. \n is next line, right? Sorry, it's \0. I'm sorry. Cool. So, okay, let's solve these questions. Again, we will solve tons of questions related to pointers in this week and in this live session and the coming live sessions. Some of the questions that you're asking, we will have variations of those in the next live sessions. First, let's solve the questions that we have here. Yes, it should be it should be /0. This is \, right? This is /. I keep getting confused with those. Cool. Okay, so here comes the second question. Again, please be careful. This is a very common type of gate question. You'll see this type of gate questions very often in gate. Again, some of you are asking for what if the code is slightly changed. My suggestion is just go to an online debugger or online, like I told you about online GDB, right? You can go there, write your code, see what is happening internally, right? So all the what if questions, just try to understand it from the foundational concepts of the compiler design that we have learned, and also C programming. Varun, please post your question at the end. I'll answer it. Let's go with the flow right now. You have a question about the scholarship test. I'll answer it at the end. I don't want to disturb others' flow of solving this problem. Again, I'm already seeing a lot of variability in your answers again. So please be careful, think through it carefully. That's extremely important. Please don't come to a conclusion in a hurry. Please think through carefully, very, very carefully. Let me just type it in an online debugger and see the answer myself, because I've not done it. I've just solved it by hand. I just want to do it to be sure. Okay, got it. Sorry. Yeah, anyway, I've showed you the answer. Yeah, I just wanted to be sure because I solved it by hand. I didn't actually put it on an online or GCC compiler. Anyway, so most of you, as I've shown you, right? So any of these code snippets, you can always type it in an online. I mean, this is what we also use in our course videos. So it's basically called online GDB. I really like it because it's extremely simple. You can, if you want to try some test code in various languages, you can do it. I often use this for C. So, okay, so the solution to this is, the solution to this is D. As you see, if I just type this in online GDB, or this basically uses a GCC compiler, right? So it gives 1467 as answer. Now, what is important is in an examination setting, you don't have access to a GCC, right? So you'll have to figure it out on your own. My answer that I got was also D, but I just wanted to make sure because a lot of students were also putting B as an answer. Okay, so let's go step by step. I'll explain this. So you have C equals to 3, A equals to 2, D equals to 5, K equals to 7, and B is just initialized. And then B is allocated this value. Now what we have to do here is we have to evaluate this, right? Now if you think about it logically, so what happens here? You have a C++ star D++, right? Again, for this question, all you have to know is the precedence and, so if you just Google search for it, you will get it. Precedence and associativity in C, right? There will be hundreds of websites that will show you. Like here is Geeks for Geeks. Okay, do they have a table? I hope they have a table. Yeah, so they have this table, right? So you have the parentheses, right? Then you have post increment. If you see, the post increment has highest priority, and it's a left to right. So you have priority here, and you have associativity. So if you can just go to you can go to tutorials point. Okay, so this is a type of diagram that I often remember. Again, you have to know this. Unfortunately, there are a few things that you have to remember by heart, some of these. So if you know this, it's fairly straightforward. Then it's all about simply working it out. So look at this. So this is a post increment. This is a post increment. You also have a post increment here. But here the C's first value will be stored. Look at this. C's initial value is 3. D's initial value is 5. Right? Apart from the post increments, the next thing that you have in terms of priority or in terms of precedence, the next most important thing is the star that you have here. So here the value that will be used is 3. And this line is, remember, this is executed. This will also be executed. Okay. And there will be 5 here. But when it's being used here, because this is post increment, C and D will only get incremented. So C will become 4, D will become 6 only after the statement is executed. Right now they're still 3 and 5 only. Okay. So this increment will happen post, because it's a post increment, right? Post the execution of this. So you have 3 into 5, so this becomes 15. Okay, let me erase this. So the moment you have this whole thing evaluated to 15. Now you have C less than, again, what is the next thing? So if you just remove this whole thing, in precedence, the next thing is plus. So D plus 15. Remember, D is still 5 here. D is still 5 because D will only get incremented to 6 after the whole statement is executed. Okay, so 5 plus 15 is 20. So you still get this whole term, this whole thing will be 20 now. This part will be 20. Okay, so this whole chunk. Now, if you see the precedence, the next thing is less than. So what is C? C is 3. Is C less than 20? Yes, that is true. And true by default, the Boolean true is represented in C programming language by default by 1. So this whole expression now got evaluated to 1. The next thing that you have here is this double bar, or basically it's your OR, right? So it's basically your OR, right? So if you go to precedence, the next thing in the precedence is this OR. So this whole expression is 1. Remember, this whole expression is 1. Then you have OR. Anything with 1 followed by whatever expression you have here, right? 1 or anything. 1 or anything. What happens here? This whole anything will not get even executed by modern compilers. Even C programming language says shortcut this whole thing. So this is basically called short circuiting, not called shortcut, it's called short circuiting. Okay, because whatever is there, the resultant won't change. So whatever is here does not even get executed. This whole thing will not get executed because 1 or anything is always 1. So your B will have a value of 1. Most importantly, this whole chunk does not get executed, which means K doesn't have an option to get incremented. So K does not get incremented. Okay, but as soon as this whole statement gets executed, your B equals to 1, your A stayed the same, your A stayed the same. your C got incremented because this got executed. This statement got executed, we use the current value of C, but because there is an increment here, C would get incremented later on to 4. Because this also got executed, right? So D will get post incremented to 6. Since this statement did not get executed, K will remain the same. So what is the question here? B, C, D, K you want to print. B, C, D, K. It will be 1, 4, 6, 7. That's it. So this is a standard medium level question by gate standard. We just made it slightly tricky by having the short circuiting. Again, short circuiting is a very common strategy that people who set the gate question paper typically focus on. Okay, so if you know about short circuiting, like the 1 or anything type of setup, or 0 and anything, even if you have this sort of thing, right? 0 and anything will always be 0. So this whole anything will not even get executed. Similarly, this whole thing will not get executed because this evaluates always to 1. So if you know about this concept called short circuiting, again, this is something that we described in our compiler design. We described this, if I'm not wrong, in code optimization of compiler design, if I'm not wrong. Okay. So if you know the precedence of operators, this is a simple question. If you don't know, then it becomes tricky. I've seen most of you choose between B and D. Again, we also checked using a GCC compiler. D is the right answer. That's what I also got, but I didn't check it in a GCC compiler. I wanted to be sure because some of you were putting out B as the answer. Cool. Okay, I hope this is good. This is good. Okay. Again, it's left to right, right? Again, some of you are asking about why this is executed, why that is not executed. Look at also the associativity, right? So precedence and associativity of operators in C. Right, so if you see the okay, so not this doesn't look okay. Let's go to University of Ohio, UIC. I hope this is okay. So this is good. So if you see this operator, right, if you see the logical OR operator which we have, this is done left to right. Okay, which means the left part. Again, the associativity is also important. Again, the trickier parts is the associativity for these operators is right to left. That's where we often get confused. We often do left to right, but we have to be careful with these operators that they're right to left. There are also a few other right to left like these, like assignment and things like that. So remember that logical or associativity is left to right. That's why first the left part is executed and then the right part. Okay, so that's also an important thing that you have to keep in mind. That's a follow-up question that somebody asked, so I just tried to answer that. Cool. Okay. Okay, so this is good. Okay, so let's go to the next question. This is also an interesting question. Again, this is a simple question about pointers and arrays. Again, somebody is asking about, does the expression get evaluated from left to right? It depends on the operators that you have. Every operator either has a left to right, depending on the associativity. Either it evaluates left first or right first. Cool. Let's answer this question, folks, now. The third question. Somebody asks, how do we remember associativity and precedence? I remember telling some mnemonic in the course videos. So some memory trick to remember it, if I'm not wrong. That's how I used to remember when I was a student. Now I just look it up. But if I have to prepare for gate exam, I'll keep some memory trick. The way I also do it for theory of computation, for properties of various languages. Like closure properties, that's what I mean. Anyway, back to our question here. This is also a very standard gate-like question. Again, thanks to all the other students who are also answering the follow-up questions by others. That's always very good to see. And yeah, Pradeep mentioned a very interesting Puma is rebel is a shortcut. Yeah, I think yeah, that's what I also remember telling in my course videos. Yeah, Puma Rebel Tag. Yeah, now I recall. Thanks. Thank you, Raghu. Anyway, let's focus on this question. We'll come back to the general topics at the end. Let's solve these questions first, so that students who are here only for discussing the questions, they can finish, and if they have to leave, they can leave, and we can continue the discussion. Again, as a simple rule of thumb, always try to draw diagrams. That has helped me enormously to avoid silly mistakes, even in C code. That has been my general strategy everywhere. It has also helped our mentors, a lot of our students also improve to avoid silly mistakes. This is a simple question about array of pointers. We will see more interesting questions in the next live session as usual. Good. I see most of you getting the right answer. Anyway, let me elaborate the answer itself. Most of you got it right, which is always encouraging. So this is sort of like a medium level question by GATE standard. It's not tricky. That's why we have not added anything additionally tricky in this question. It's a fairly straightforward question, if you know. So this is basically an array of pointers. That is the important thing. The moment you know that logic, everything falls in place. So the moment you have something like this, again, for most pointer questions or pointers of arrays and pointers of functions, I try to draw a diagram like this. I say, oh, okay, so this is basically an array of pointers. Okay, that is important, right? So I have an array where each of them is a pointer. Okay, something like this. The first one is pointing to yes. The second one is pointing to true. Again, these strings are also stored, right, in memory, obviously. Then you have required, right? Then you have general. I'm not writing the whole thing. Then you have using. Then you have cancel, right? So your str is basically, remember, it's basically this array of pointers where each element itself is a pointer, which means each element is storing an address. That's important, right? So you're calling this function called foo_str. Okay, so you're passing str, and as usual, as you expect here, this is a double pointer, right? Because remember, str itself, because it's an array, it's the name of the array, this itself is a pointer to a pointer, because these are pointers, right? These are all pointers, right? These are all pointers. So str is basically a double pointer. Okay, I also sometimes use star to represent that it's a pointer. So each of these is a pointer. This is a double pointer. Okay, so you're passing the double pointer. Now we are now creating a single char pointer here, ptr1. But what is ptr1 here? Now this is where things get interesting. Let's dive into this a little more. So here it says assume integer size is of 4 bytes, which means this thing will get size of int will be 4. So we have ptr plus equals to 4, because this is in parentheses, doesn't matter, it will get first evaluated. Ptr plus equals to 4, which means ptr equals to ptr. Again, this is ptr. Ptr is nothing but str now. Remember, ptr is nothing but str because you passed it here, right? Right. So ptr equals to ptr plus equals to 4, which means where will ptr point to? This is 0, 1, 2, 3, 4, 5. So ptr plus equals to 4 because ptr is actually pointing to this, right? Ptr is actually pointing to this because ptr is same as str. Now ptr plus equals to 4 means ptr will now point to, it will no more point to this. It will point to 0, 1, 2, 3, 4. So it will actually point to the 4th element here, right? That's important. It is going to point to the 4th element here, or in other words, it's going to point to the fourth pointer in this array of pointers. It's always important to vocalize things so that you understand what's happening. Then you have an indexing of -2. What does -2 indexing mean? You'll go 2 steps back, right? Because remember, it's basically a pointer, right? At the end of the day, it's a pointer, right? So this whole thing is basically a pointer to so it's basically pointing to this, and you're saying go 2 steps back, right? So if you say go 2 steps back, it will actually literally, so ptr1, now ptr1, you're not saying go 2 steps back, you're saying whatever is there. So this is pointing to this, -2 means go 2 indices back, and that is what ptr1 will be. So PTR1 is equal to whatever is the value stored here. Look at this, PTR1 will be equal to whatever the pointer value that is here. It's not pointing. PTR1 is exactly equal to this value here. Okay, it is because you're doing this is like array indexing, right? This is exactly like array indexing. When you have a minus 2, what does it mean? It means value stored at address of a, right? It's equivalent to value stored at the address of a minus 2. This is how you can convert between these two notations, right? Okay, so same thing we are doing here. So PTR1 will be equal to this pointer address. Now we are saying print it with next line. This is like print new line basically, right? So when you say printf percentages PTR1, it will actually print required. That's the answer here, right? Yes, so required is the answer here. Simple. Again, this is an easier example of array of pointers. We did not add anything tricky. This is often considered medium by gate standard. In the coming live sessions, we will have medium plus tricky questions on array of pointers, pointers to functions and things like that. So this is straightforward. I think most of you got it right. Most of you got it right. Cool. Again, the size of int is already mentioned here, that integer is of 4 bytes. That's what would have avoided all the confusion. If this statement was not there, then you can't say exactly what will happen, because it depends on the computer architecture, whether you have a 32-bit architecture or a 64-bit architecture. It also depends on the C implementation itself, on how many bytes to assign to an integer. Okay, cool. Okay, here comes the fourth question. I'm just noting down points that I'll describe and discuss a little later. Again, this question is considered easy question by gate standards. We wanted to have a few easy questions also. Good. Most of you got it right. It's an easy question. It will be some garbage value. I'll explain the solution in a minute. So one of our students has said, why don't we have a timer of few minutes, depending on how much time we have, and solve 10 questions. The problem with that, Ayush, is right now most people are just going through the subject the very first time. We are not looking at the volume of questions. We are looking at solving the problem thoroughly and understanding how to solve and how to avoid silly mistakes. If you're looking at volume of questions, anyway, in our course, and we have almost close to 5,000 to 6,000 questions. So volume is never a problem, right? It's about going through the detailed solution step by step is what is important. And additionally, the reason we do these live sessions is to keep students on track with their preparation so that they can follow with us. That is the whole objective of these live sessions. We have a few thousand solved questions also in the course videos. These are just, what we're doing here is just a minuscule part of it. But we thought this will help students stay on track. I hope you understand. Again, slowly we'll increase the number of questions. Cool. So this is an easy question. Let's answer this question. So you have a float A, which is 5.375. Okay. So you're storing 5.375 in some memory location. Again, you don't know, it could be 32-bit. I mean, depending on, again, since you're using a floating point, I'm assuming it's single precision. So it could use IEEE 754 format that we studied in our digital logic design. I'm trying to combine concepts from various topics so that you get a better appreciation of the subject. You have a char pointer, you have int I, p equals to address of A, right? So A is not a pointer, A is basically where this memory is, where this is stored. So address of A, which means you get the address of this. Suppose imagine this is address 2000. You are now typecasting it into a character pointer. So P is basically a character pointer. P is basically a character pointer pointing to location 2000. Then what are you doing? I equals to 0, I less than 1, I plus plus. You're printing P3, right? P3 basically means, again, this whole floating point value, how it is stored depends on what format is used. If I'm not wrong, the GCC's C99 version uses IEEE 754. If I'm not wrong, they use this, but they have a few caveats where they could use different formats based on how you compiled the compiler itself or how you set up the compiler using various flags. So we can never assume that the compiler that is given to you uses IEEE 754 always. If it is given that they could combine this question and make it more interesting by saying, hey, what is the output of the following code, assuming that single precision floating point values are stored using IEEE 754. Then the problem is much more fun because then they are combining C concepts with DLD concepts. Then you have to take this number, convert it using what we discussed in digital logic design, convert it into the whole binary vector, and then look at the third location. So imagine if this was stored in 4 bytes, right? That's what IEEE 754, right? 32-bit representation. Then the char basically is 8 bits. So this is 0, 1, 2, 3. So P3 will point to this. So you can output the last byte of values. But since in the question, nothing is told to us about what is the format in which the data is stored, what you can guess is, you can guess that it will be some garbage value. You can never be certain about it. Okay. But the same question can be made much more fun by just adding one more line to the same question. I'm just giving you a variation where they could say, assume that the C compiler that you're using uses IEEE 754 format to represent single point floating values, and float creates a single precision floating point value. If they just say that, the problem becomes much more fun. So you can tackle it on your own. It's always fun. Cool. So I hope most of you got it right. This is a simple problem. It's an easy problem. Okay, sounds good. So let's go to the 5th question now. Chetan, to answer your question, on the same computer, using different settings of GCC, you can get different outputs for the above question. So it's not just system dependent, it's also dependent on the compiler that you're using and the compiler flags that you're using. Guys, please stop being dumb. Why is the answer A? Please read the code, for heaven's sake. Please read the code. Everybody who said A, you better get your game together. You have done a deadly silly mistake today. Please don't say that A is the answer, for heaven's sake. A is not the answer. Everybody who said A, please make a note in your notebook today saying, I will not do this silly mistake next time? I've seen so many people just putting A as the answer in like 10 seconds. I was shocked. This is an easy question. Please don't lose marks on this. Come on, guys. This question is intentionally made slightly tricky. Everybody who said A, please make a note. Please make a note in your notebook and say, I will not do this sort of mistakes. I'll tell you what mistake you did anyway. Thankfully, some of you are correcting it. I was of the impression that this is a trivial question that everybody would answer and we'll pack it up in 2 minutes. Thanks to our mentors who set this interesting, tricky question. Good. Anyway, let's solve this. Your n equals to 0. You have a for loop. Look at this. Look at this semicolon. I have intentionally, even though our mentors did not give it, I have intentionally created this indentation to confuse you. But you have to be careful. Look at this code here, for heaven's sake. So n equals to 0, which means in the condition part it's 0. So this will not run anything, and there is no body to the for loop. Look at this. There is no body to the for loop. This is not inside the body. Indentations don't matter. We are not writing Python code. We are writing C code. Okay. So nothing will happen here. Okay. So n equals to 0. What is this cap operator? It is not exponentiation. We are not writing Python code. In Python, 2 exponent 3 is power. It's like a power b operation. We are not writing in Python or other languages which have the exponent operation. In C, this is XOR. Right? N XOR 3. What is n? N is 0 to start with. 0 basically means all zeros. Then 3 basically means 0, 1, 1. Right? Binary. So you're doing a binary XOR operation. What is a binary XOR of 0, 0, 0 and 0, 1, 1? XOR will be 1 because they're different. XOR is 1. They're same, 0. For all other bits will be 0. So n is n XOR 3. N XOR 3 making n equals to 3. When you print the decimal value of 3, you will get 3. So please make a note in your notebook to read this carefully and to keep a note of all the operators in C programming language. This is an XOR operator, and always look at whether there is a body or there is a column. Please make this note because these are simple questions where students will be in a hurry to solve. They will lose marks. Please don't do that. Please don't hurt yourself with silly mistakes. Okay, cool. This is an easy question. I was like, everybody would get it. That's okay. That's okay. Somebody said I got 2 marks. That's okay. You got 40% marks. Think about it like that. So let's go into general Q&A now. Indentation, actually one of our mentors didn't add indentation. I intentionally added indentation because I knew that people who have written code in Python would get confused because I write 90% of my code in Python nowadays. Anyway, it's okay. It's okay. Happens to all of us. We all make mistakes. Life's lessons. Okay. Questions that some of you have asked during the live session about the test series itself. The test series, we will hopefully launch it sometime later this week or early next week, worst case. Okay. It will be available. We'll push out a notification on our YouTube channel also. And okay. So Ayush has a very nice question. Let me answer that because it gives you a broader context of career. Does doing an Mtech degree from an IIT or a top university give you an edge in promotions at top product-based companies? No. In a product-based company, your manager doesn't care which university you came from. A lot of my peers did not know which university I came from. They don't care. Your promotions or your growth in a company is mostly because you did something that is useful for the company or the customers or the team. If you go do a startup, nobody cares whether you come from Harvard, Stanford or IISc or IIT. Nobody gives a damn. It all depends on what value do you create for your customers at the end or for businesses that you work with. That's all matters. Nobody cares about your degree beyond your first placement. Let's be honest here. Okay. So it's only your skills, your expertise, and what you can build, what you can deliver, what you can design, what you can conceptualize, that's what matters, not your degree. Like, I've managed people who had PhDs from top universities of the world, and oftentimes we did not care. Like, I've been in lot of annual review loops. Nobody cares about your degree. People only care about how well you have done in that year and the previous years. That's all. So Sukanya says, should I sit for campus placements? Yes. Please don't skip your campus placements because you're preparing for GATE. Please do sit, because in case you don't get a GATE rank, a good GATE rank that you're happy with, you always have placements as a backup plan. Again, you should always make smart. You should take risks, but calculated risks, smart risks. Don't just dump your placements for this. Of course, whether you join or not is a secondary thing that you can decide at a later point of time. Okay, so Rajdeep says, till which month should one finish the first iteration? I think I've mentioned this multiple times. There is no right answer to it. We have seen people who finished in June, July who didn't get any rank in GATE. We have seen people who finished in Jan who got good ranks. So what is important is not finishing your first iteration fast. What is important is how thoroughly you have done problem solving. You've worked examples, you've solved problems, you've gone through the concepts in the first iteration. If you do it thoroughly in the first iteration, even by Jan or even by late December, early Jan, you can do quick revisions after that in the next 45 days and go into the examination. You'll get a good rank. That doesn't matter. MRK says, GATE versus service-based company placements. Don't say versus, because even when I was in BTech, I studied in a small engineering college. I attended all the placements. I was also the placement coordinator. I was the first batch in my college. We didn't have placements. So we went around, requested other colleges, companies to allow us when they were conducting placement drives elsewhere. I had a couple of offers from top services companies, not product-based companies, obviously. I had a couple of offers. I kept them handy in case something goes wrong. Okay, I never ended up joining, but it's always good to have that handy, because you never know whether you'll get a good GATE rank or not. Even after I got a good GATE rank in my third year, I still sat for these placements because I wanted to have a backup plan always. It's always a good idea to have a backup plan in case something goes wrong. That's what is smart risk, right? So Raghu has another question. If I want to do a startup, will IIT give me a good platform? Very nice question. IIT Delhi has a huge startup ecosystem because of multiple reasons. A lot of good startups from IIT Delhi came out and have done very well. So the IIT brand will certainly give you connections which are helpful, and it might also introduce you to some venture capitalists, but it doesn't guarantee success. Remember, I've seen people who came from no-name colleges who have done phenomenally well in startups. I've seen startups by the brightest of brightest at top universities, not just of India, of the world, which have collapsed, which have not worked out. Because in a startup, while your college brand or your company brand might help you with the initial push, just like in placements, in the long run, you have to create value to your customers or to your business partners. That's the only way you succeed in a startup. There is no other shortcut. Simple as that. Pavitra says, I passed out this year but did not get a good GATE score. Should I drop a year or not? Please don't drop a year. Try to get into a job and parallelly prepare for GATE. Because you said that you did not get a good GATE rank last time. I'm assuming you've prepared for GATE once. Build on top of your preparation. Focus on areas that you're lacking. You'll certainly do well later. Okay, cool. Sunidhya says, how is the entrepreneurship environment at Iisc? Honestly, it is non-existent. It doesn't exist. Okay, startup environment doesn't exist at Iisc, and I have to be honest about it. Okay, it simply doesn't exist. Research environment is terrific, not startup environment. Okay, so I'm from ECE and I'm preparing for CS GATE. This is from Anup. Will my branch reflect in my Mtech? It doesn't matter. See, as long as you crack GATE CS exam, you have all the foundational computer science knowledge, right? Like beyond, later on, people even will forget that you've done your bachelor's in ECE. because you'll most likely do your master's in computer science or a related field. And you have all the foundations because you've written GATE CS exam, right? Of course, being a ECE student, you will have a small advantage when it comes to a deeper understanding of, let's say, computer architecture or communication networks and stuff like that, which could help you in the long run. But in terms of your education at top universities or placements after that, even in the few years of your career, it really doesn't matter. Of course, you have some good knowledge of mathematics and communications and electronics that could help you in the long run. For example, I had friends of mine at Amazon who were ECE students, who did undergraduate level ECE. Their foundations of communications, their foundations of entropy, concepts like Shannon's entropy, they were very strong with it, right? So that's the advantage they had. Of course, I had to pick up those concepts on my own at a later point. Anonymous says, how to handle so many subjects in your brain? Revise, revise, revise. This is a standard strategy whenever the syllabus is vast, whether it is the GATE examination, whether it's the UPSC Civil Services exam. For all examinations where syllabus is vast, revision is the only trick, because we humans are not good with having great memory. Only a very small percentage of us have like photographic memory. Most of us are mere humans. Okay, sounds good. There was also one question about the scholarship test. Whatever free videos we have provided, that is sufficient to get good marks in the scholarship test. You don't have to prepare from anywhere else. Of course, if you have time, you're most welcome to prepare from standard textbooks. But everything that you will encounter will come from, again, you can see the last year's scholarship test that we have made publicly available with the same syllabus. So the syllabus is basics of data structures, algorithms, very basics, not too much of it, like less than 1/3 of the syllabus there, and a little bit of math concepts. Just please watch the videos, see the solved problems, and you're good to go. It's as simple as that. Okay. We have one more live session before the scholarship test, so it's at that time I'll tell you all the very best. Okay, folks, let's wrap it up. Thank you very much for this session. Again, I hope all of you are staying safe. It's extremely important to stay safe. Let's not get our guard down because the wave is down. Double mask, wear a shield if you can, go out only if it's absolutely necessary. Let's do our part and get vaccinated if you have the facility or availability of vaccines. Thank you very much. Bye-bye.